We have been working with three types of quadratic equations. We've been working with what looks like, or what we call standard form. And that's your ax squared plus bx plus c 0. That's standard form. What's that? Was it 0? Did I say 0 or what? Oh. Equals, I'm going to leave it as equals y, because that's what I meant. And then we have vertex form. And that's your y equals a times the quantity x minus h squared plus k. And do you guys remember what h and k stood for?
Yeah.
H and k is your vertex. Very good. And then the last one that we dealt with was called intercept form. Intercept form was dealing with the zeros of the parabolas. And it looked like this. Y equals a x minus p x minus q. P and Q are the zeros. And what I mean by the zeros here, if I'm looking at a graph, those are the zeros. That's your P and Q value. Okay. Usually when you factored stuff, whenever you factored anything, it was you always factored it into two terms, x minus 3x plus 2. Your zeros were 3 and negative 2. That's kind of what you're looking at here. All right. So we have three forms to look at today, three ways of doing things, and a total of 6 examples.
That means there's 2 of each.
And I want to start with vertex form because I think it's the easiest. So what's going to happen here is you're going to be given a vertex and a point, and you have to write out the equation in that vertex form. So, can I go to another one, or you're almost done yet? All right. What's going to happen here is I'm going to write a quadratic function in vertex form, your y equals a times quantity x minus h, given this information, given all that information. When I look at the information that I'm given, I have a vertex, 2, negative 3, and I have a point, 4, 1. Do you agree?
Yeah.
In this vertex form, how many variables are there?
5.
How many of them do I know?
42.
I know 4 of them.
You saw how, right?
I'm solving for A. This is my H, my K, X, and Y. I'm using a lot of substitution here today, guys. If I'm writing out in standard or in vertex form, Y, A, X, H, K, there's 5 total variables there. You're going to be given 4 of them. Solve for the missing. So in this case here, I can go directly into substitution. If my ordered pair is 4, 1, so that means 1 has to equal A times, well, what's X? 4. H is 2, quantity squared. Now when I write out K, do I write it as plus 3 or minus 3? Minus 3. Because H and K is 2, negative 3. Yes, sir. Well, what is a positive? 2 is positive, so that's why it's written as H or as X minus 2. H's are always the opposite of what you see. K's are always the same. So now, what's 4 minus 2?
2.
What's 2 squared?
4.
So I get 1 equals 4A minus 3.
Add 3.
Add 3, and then what?
Divide by 4.
What's A?
1.
Very good. When you write something in vertex form, what do you always have to have in there? A, H, and K. So your final answer is y equals A, x minus h, quantity squared, minus 3. And that's it. Do I even really need to write the 1 in there for A?
No.
I really don't. It just so happens that the A value is 1. If my A value was 3 halves, what would I put in front? 3 halves. Okay. All we're doing here today, guys, for writing into, in this case, vertex form, you'll be given 4 variables, and it's always going to be solve for A, and then just resubstitute back in. Okay. Want to try one?
Yeah, let's do it.
The enthusiasm. And you're not always going to be given a graph. You might just be given a vertex and a point. What are you going to screw up? I heard someone else say, yeah, the negatives and positives, but you're going to accidentally switch them. You'll say the point is the vertex is the point. So when you get to that and you're starting to go through your vertex and point, they're labeled it for you. Take 1 second and label the vertex as H and K. Label the point as X and Y. And also, if you have not already state what vertex form looks like, write it down a couple of times. I know it's the same. It's just done one.
Isn't the exact same thing?
Not really. It's a little bit. It's, I know. Right? I just so happen to randomly pick a problem that works like that. That's Murphy's Law for you. Now, what I was meaning by that, guys, by putting these in, that way you know which one's which. Just so it helps keep things clear. I know it's yeah, we're making progress. I know. But you get the idea. I should have fixed that, but I forgot.
Hey, Mr. Murphy, how are you?
I'm doing well, thank you.
You excited for tomorrow?
For conferences?
I think it's actually Thanksgiving.
Isn't that?
No, thanks. Or like it's the proceeding. It's like a few weeks
No,
before. It's like a
Thanksgiving.
2-week countdown to Thanksgiving. 2-week countdown or 3-week countdown? We'll start counting because
3 equals A,
tomorrow's the 7th.
4 minus 2.
Thanks, everyone. It's the,
Oh,
is it always the
solving.
fourth Thursday of the month?
I'm just substituting that in.
Yeah.
Wait, no, shouldn't it be -1?
Yeah, I thank you. Hey, did you guys get 4 equals 4A?
I think.
It just, all right. I realized this earlier and I forgot to change it, so yes. But you get the same idea, okay? Now when you're done, you just write it out. Y equals x minus 2 quantity squared minus 1. And that's all you have to put. Since the A value is 1, you don't have to have it out front. What do you think is going to change when you have intercept form?
Nothing.
Nothing. You still have 5 variables to start with. You're given 4 of them. What do you think you have to solve for?
A.
There you go.
Plug her in.
What's that?
Are we doing intercept form now?
Yeah.
I thought.
I think that when we do standard form is the trickiest of them all because there's a lot more work. It's not difficult work, but there's a lot more of it. Intercept form and vertex form are fairly straightforward. Once again, when I'm dealing with intercept form, that means I'm being given my zeros. That means I know what my P and Q value are. So, and I also have a point. There are 5 total variables, one of which is repeated, which means you use the ordered pair of -1 and 2. You use that -1 twice. You don't know what your A value is, but what do you think your A value's sign will be in this case?
Negative.
If you don't get a negative A value, you're probably doing something wrong, especially because they're giving you a graph. The graph is moving downward, that means A has got to be negative. Yes, sir?
So P is negative
Yes, P is negative 2. Now, what I want you to remember here is, if you had a factored x plus 2 and an x minus 3, when you had that something factored out, what were your zeros? Negative 2 and 3. That's what they're giving you. They're giving you the zeros of the function. All right? So when you substitute back in, it is 2 equals a negative 1 minus a negative p, which is? What's minus it? What's my p value? Does it matter which one's p and which one's q? So can I write minus a negative 2 and write plus 2? And then just do the same thing. Negative 1 minus 3. Once again, solve for a. Yes, sir?
What is A on the graph? Like, what is it?
A represents, you want to think of it, it's kind of like a precursor of slope, the rate at which it's rising or falling.
So could you tell without by the graph by
Not really.
it's like
It's not linear,
yeah.
so you really can't go that way. But the A value, at least if it's positive or negative, tells you the uppercut. You can tell if it's fatter or wider. That's about it. So here you get A times 1 times negative 4. So 2 equals negative 4A. What's A? 1/2.
Most likely.
Now, that would be our luck, right?
I think.
Just guess one.
What's your last step?
You have to
Opposite.
rewrite it.
Just rewrite it. I'm not worried about slopes or anything. You just rewrite it. Go back into the intercept form, so y equals negative 1/2 x plus 2 x minus 3. And you're done. That's intercept form for that quadratic. Okay. You have 4 of the variables, 4 of the 5 variables, solve for a, and rewrite. Do that one. Okay, try that one.
Do you want us to use that same one?
Yeah, this one's the same form. Fill in the blanks. 2 is a negative 2 plus 4, negative 2 minus 8.
An hour after, right after.
No, you can just sing it.
You messed up 8.
Wow.
I think it's plus 4 minus 2.
You see Rick's whole problem.
No, negative 4.
Rick's
So
whole
why-
thing.
why-
How about I should just start all over?
Yeah,
There we
there you
go.
go,
All
there
right,
you go.
why? That's this thing here. 8. Good morning.
Morning glory.
What's the story? Am I okay so far?
Yeah.
I'm not screwing up to like horribly bad now.
Minus.
Made me nervous for a second. Like, I don't know what I'm doing anymore. I forgot. You get negative 2 times negative 6.
Well. You.
You get 2/3.
Yeah.
Y equals 2/3 x minus 2 x plus 2. Does it matter the order in which you put your p and q?
Yes.
It really doesn't. Multiplication doesn't matter. Order doesn't matter. What property?
Spoil.
Order doesn't matter when you multiply. What property?
Multiplicative.
Thank you. Commutative. Now the last but not least one, the one that takes the most, the one that you guys all are going to hate me for because you have to do a system of equations.
Why do we have to do it?
Because sometimes you're going to be given 3 points, and you will see this again with polynomials, and you'll see this again in pre-calc. You'll have to come up with the actual values themselves And we're going to go into standard form. Standard form. Standard form is your ax squared plus bx plus c equals 1. And now what I want you to look at here, one second. What I want you to look at here is that I have 3 sets of x's and y's, correct? Which means I'm going to create how many equations? 3 of them. So what you're going to wind up doing here is you're going to substitute in for x and y 3 times. And you're going to solve, you're going to set up a system in terms of A, B, and C. Yeah.
So this is like when we had what we did last chapter.
Yep.
Wait, at least use our calculator.
Yep. That's the whole idea.
Like for the matrix.
That's the whole point.
I was sorry.
Duh. I tried to prolong the pain as long as possible here. So you wind up with the following. A times -1 squared plus B times -1 plus C is 5. That's what the first equation would look like. Do you agree? Alright. The second equation would be A times 0 squared plus B times 0 plus C is 3. Then I do the third equation. A times A times 3 squared plus B times 3 plus C is 9. And what you're doing is you're going to create a 3 by 3 system and use an inverse matrix. Now, you don't do that by hand, ladies and gentlemen. What I want to look at here is as we start to write these out, I want you to see how this is simplified. What's -1 squared? What's -1 squared? 1. So this is 1a minus 1b plus c is 5. I'm simplifying. What I'm doing here is I'm trying to come up with the coefficient matrix by simplifying before I go to the matrix. Okay? What's 0 squared?
So there is no A.
So I have 0a plus 0b plus c is 3.
So C must be 3.
I'm guessing you're right. What's 3 squared?
9.
9a plus 3b plus c is 9. Now, I could be an ogre and tell you to use substitution and do this all by hand.
All right, you Shrek.
Yeah. Or, if you create from that information, you can create an inverse matrix. Remember, when you're doing inverse matrices, can I slide this up just a little bit so we can see this? Can I leave it there? Is that all right? When I'm doing the coefficient inverse matrix, it's a 3 by 3, 1, -1. What's the value for C? 1. Very good. 0, 0, 1, 9, 3, 1. To that matrix, what do I have to do? Inverse. And what am I multiplying it against?
The answer is
539.
539. Very good. Now, the way that we set this up, a 3 by 3 times a 3 by 1 is going to kick out a 3 by 1. That 3 by 1 is your answers in order A, B, C. Okay? Look, there's a use for matrices. Yes, sir.
Why is the bottom
Here, the coefficients for all that whole column of C's is always 1.
1? Oh, right.
Because when you think about your standard form of the equation, it's ax squared plus bx plus c. There's no x component to the c value, so it's always going to be 1.
So the only difference, if you would just square, let's go back up. Yeah,
It's usually
square A, or you know what I mean.
I know where you're going, and you're right. You're right. What do you guys get for an answer?
5/4, -3/4.
You did something wrong.
Yes. I did it by hand too.
1, -1, and 3. That's your answer.
I did that by hand.
This is A, this is B, and this is C.
Because you just substitute C and then just do 2 by
You can if you want. Yes, sir.
I was just wondering how much that should credit was originally.
I don't remember.
Is it more than a point though?
Yes.
Will it break
Now-
or
Oh, is it?
by 8%?
What are we talking about? Square.
Now, if, remember, I'm looking to get it in the form of ax squared plus bx plus c. What's A? What's B?
If you had masking tape on there, it would work.
Yeah. X squared minus x plus 3 is your answer. X squared minus x plus 3 is your answer. That's what that quadratic will look like given those 3 points. Now, what were you saying a second ago about this?
When we would have changed the first column.
Isn't this first column is what? X squared, right? What's the second column?
X.
What's the third column?
No X.
What's it always?
No, that's
And what's the answer column?
Y equals. So what are we?
Look at your ordered pairs.
Oh, man.
What's -1 squared? 1.
Why couldn't you said that in the first
Because I'm a
place?
jerk. What's 0 squared? 0. What's 3 squared? 9.
I feel like this is all math is this is a really complicated way to get an answer, and then, oh, just kidding.
The order
Here's
I had to
easy
make it
way.
sound like it was difficult.
No!
It really is quite simple. Remember, when you're doing these,
That's all math is.
think of it as every column means something. X squared, X, 1, Y's.
Can you scroll back up to like?
I'm going to do another one. Show you the same shortcut.
Except we don't have to do all the trick stuff.
Oh, God, no.
You have to do with the what?
So it's like
Shortcut it.
-2 squared is 4, right? Okay.
This first column is always
4,
x squared.
4, 1,
What's -2 squared?
4, 4.
What's 1 squared?
9,
What's 2 squared?
4.
The next column is always x.
Oh, this is so much easier.
I had to make it sound like it was difficult.
You always do.
That's how I roll.
Wow.
And what's the third column always going to be? 1s. What's your answer column?
-1, 11.
Works every time.
Oh.
Yeah.
Uh,
It'll work every time. And now remember, this is going to give you your answer in terms of A, B, and C. And you still have to go back and rewrite it as ax squared bx plus c. All right, you still have to do that as the last step. But what's nice is that when you're given the ordered pairs, you can go right for it. One thing I will remind you guys of, a lot of times if you get error messages when you're doing your matrices, if you're doing an inverse, you probably have a sign that's incorrect, or you have an entry that's incorrect. Because if that occurs, it means you're probably getting a determinant of 0, and you can't have that. Yes, sir?
How many times that happens is if instead of negative you do minus.
Correct. That happens a lot. If you hit the minus button instead of the negative button. Thanks for reminding me of that one. I forgot to do that too. All right? So when you inverse this one out, what'd you guys get for A, B, and C?
3, 7, 1.
3, 7, and 1. Do we all agree? So if you have 3, 7, and 1, that means your final answer would be 3x squared plus 7x plus 1 is y. If you are not sure that you are right, how would you check that? Put it in your calculator and look at your table, right? If you put this back in your calculator and you look at your table, I sure hope those are ordered pairs in the table. If they're not, you did something wrong. I don't know. But does that make sense when you're going to standard form? X squared column, X column, 1s, Y. Okay? These are all odd numbers. That way you guys are able to check your work. I want to give you guys an opportunity to be able to do stuff that makes a little bit of sense. Now, tomorrow, with the shortened periods, we'll go through these things, go over any of the any songs you guys have. But I'm also going to come up with some review problems for us to go over the weekend, which I know you're all going to do.
If you,
We're going to go over those because I'm not going to give you the test on Tuesday. That's just really, really mean after a 4-day weekend. We will test a week from today, next Wednesday. We'll talk more about that tomorrow. I have not completely finished writing the test yet, so I can't tell you so much about it, but
Is it scary?
it's not that scary. It's pretty strict. Now that you're starting to see a lot more and more that your calculator is able to do, you can start to get the idea of the things that I'm going to be asking you guys to find. Okay? I'm not going to take the calculator from you on this one. No. Okay? Yeah, I'm not going to take the calculator away from you on this one. When we get to polynomial functions, when we do some stuff in there, I will take the calculator away, but
Hey,
next chapter. Also,